Do you remember what I told you this unit was called the last time we talked? Anybody? If you don't, that's okay. It's called tying it all together. Okay? Because it's like the last unit that we're doing, right? So we're trying to tie it all together. So everything we've done so far this year, we're trying to put all together. Because in real life, in the quote-unquote real world, do you only have problems that are just linear or just quadratic? You don't, do you? A lot of times all those things are mixed together. Okay, so that's the purpose of this unit, is to look at problems that are all kind of mixed together kind of deal. Okay? So the first part of this worksheet, 1 through 10, we're solving systems of nonlinear equations. So let's step back for just a second before I get started. Can you tell me what a system of equations is? So multiple equations, right? Just by definition, you know that equations means more than one equation, right? A system of equations. What's a system? What makes it a system instead of just like equation friends? They have the same solution, right? So they probably cross, or maybe they're a system that doesn't cross, which is its own self, has no solutions, right? So how many solutions are you allowed to get? So 0, right? For sure 0. Could you have a system with one equation? Yes? Okay. Could you have a system with 2 equations? Yeah? So for today, for the record, we have linear. You don't have to write this down. I'm just kind of giving you an idea. We've got quadratic. We've got rational. And we've got radical. So thinking about what those 4 look like, linear is a line, okay? Quadratic is a parabola, right? So like this, maybe. What's rational? That's radical, so I'll go ahead and write that down so it's like that, right? It's like half of a quadratic turned on its side, right? Rational is like this, where we have an asymptote here and an asymptote here. Remember that? Okay. So thinking about those 4 types of equations, can you think of a way to get no solutions? Now there's lots of ways, isn't there? You'd have a parabola and then a line. Those are not touching, so there's no solutions, right? You could have a parabola and a rational. Except I meant to say radical, sorry. You could have a radical and a line. Or a line like this, right? Right? So what about one solution? Can you see ways you can have one solution? So you could have a parabola and a line that goes like this, right? You could have a parabola and a line that goes like this, touches right there on the end. Or even on the side, right? You could have a parabola and your line goes like that. It just happens to touch in one place. You could have 2 parabolas. So like this and this. 1. Right? So we got 1 down pretty well, right? What about 2? 2 solutions. Oh, okay, parabola and a line through. So 1, 2 solutions. Good. A rational and a line. Yeah? Rational and a line like that. Right? Okay. What about a radical and a line? Could you do that? If you started here and went that way and maybe your line went like this. Something like that. You could have 2 solutions that way. What about 2 parabolas? Here and like that. Something like that, right? So could you have 3 solutions? What do you think? 3 solutions? Nope, only 2 equations. You got to think outside the box a little bit for this one. What if I had, let me draw this all out so I can make it, so I can see it a little easier. What if you had a rational and a parabola? Do you see them? Here's 1, here's 2, here's 3. What about 4 solutions? First of all, that's not the only way. I just kind of want to go on from here. Can we have 4? So if I had a parabola this way and a parabola like this way, 1, 2, 3, 4. A rational and a rational? Yes? Would just depend on the steepness of the slope or something? Not slope, you know what I'm trying to say. Here's 1, and then if 1 came like this, and then this one would come like this, so I'd have 1, 2, 3, 4, right? Okay. You're getting ideas though, right? I can have, okay, what about 5? If these are the functions that I can use, can I have 5? Yeah, not that I could think of earlier either. Okay, I'm not saying it's impossible. I'm saying I couldn't think of any. Okay? If you can think of one, that's great. I would love to see it. Okay? I just couldn't think of any ways earlier that you could get 5. Okay? So this is the kind of stuff that we're going to do today. We're going to work on. So I wanted to remind you what it meant to be a solution. What does it mean to be a solution? It's where they cross, right? Okay? So if we're looking at problems 1 through 10 on this particular worksheet, and it says for each problem, sketch the graphs and find the solutions of the system by determining the intersection points. Am I wanting to put these into a table and get the exact points and plot the exact points and then sketch them on the graph and find the solutions? Or are we more focused on technology today? Technology, right? I want you using your calculator. I want you to get a general sketch of where they were. Okay, if it looks like a dog, I don't want you to draw a giraffe, right? Okay, I want you to get a general idea of the sketch, but mostly what I'm concerned about right now is, do you know what a solution is? Do you realize that it's at the intersection points? Okay, so that's how you do 1 through 10. You got that okay? Let's look at number 12. I'm going to zoom in a little bit more on number 12. This doesn't say solve graphically. It says confirm graphically, which means you got to solve it a different way. Okay? It says solve algebraically. Do you remember how we would solve equations algebraically? Substitution is one way. Elimination is one way. Matrix is another way. Okay? Are those the only ways? No, that's just what we talked about in here, right? Okay? So how would you solve number 12 if you were asked to solve it algebraically? Most people would solve it with substitution. Most people wouldn't use elimination because of the fact that we couldn't get both variables, or we could eliminate y's, but x's, there's still squareds in it and stuff like that. Elimination is a little bit more difficult when you don't have everything lined up exactly the way it needs to be. Okay? Most people, not that it would be wrong, you could totally do it. Okay? Here, people use substitution because they realize this is set equal to y and so is this. And if they both equal y, then what's true about both of these two? They equal each other. That's exactly right. Okay? So they would go straight here. X squared plus 3x minus 5 equals 2x plus 1. Do you see how that's true? Okay. What kind of equation has this now become? I'll give you a hint. It starts with a Q. Oh, quadratic. Okay. Do you know any other words that start with a Q? Okay, just asking. Okay. It's a quadratic. How do we solve it? Equal to 0. Yeah, absolutely. So if I'm getting this equal to 0, I'm going to subtract 2x from both sides, and I'm going to subtract 1 from both sides. On the left-hand side of the equation, that leaves me with x squared plus x minus 6. And on the right-hand side of the equation, that leaves me with a 0. Well, now that it's equal to 0, I have several different possibilities on how I can do. Okay? I can graph it and find out where it crosses the axis, but it says clearly we want to solve algebraically, so maybe not graphing. I could use a quadratic formula. It's quadratic, in fact, right? I could factor. Is this something that would be easy to factor? So do you know what multiplies to be negative 6 and adds to be 1? Negative 2, positive 3, right? So negative 2 and positive 3. Now that I have my factors, how do I solve for x? Set each of the factors equal to 0. That's perfect. So x equals 2 and x equals negative 3. Now, did you notice how I skipped a step there? Right? I didn't write out x minus 2 equals 0 and then add 2 to both sides to get equals 2. This is something we've worked on before, and we know we can skip that step, right? Okay. Are these my solutions? What are these? Those are my x-coordinates of my solutions, right? X-coordinates of my solutions. So I know my solutions have to look like this. 2 something and negative 3 something. How in the world am I going to figure out what the y is? Plug it in. Which one? Top or bottom? Bottom. Why bottom? It's easier, right? Shorter. That doesn't make me lazy. That makes me smart because I know which one's easier. Okay? So 2. 2 times 2 plus 1. Y is 5 when x is 2. 2 times negative 3. Negative 6 plus 1. Negative 5. When x is negative 3, y is negative 5. So earlier they said, oh, they're opposites. One's always positive, one's always negative. It happens to be in this problem, right? Will it always work out that way? No. Okay, so don't be fooled by that. Yes, sir. These down here. Well, that's where we're going to next. That's a very good question, and that's where we're going to next. The answer is no. Okay, but let me show what we're going to do. Because what does it say then? Confirm graphically. So on my calculator, after it comes on, which is not going to because I'm trying to show you something. Okay, here we go. I'm going to put these two equations in. Okay, y equals x squared plus 3x minus 5. Beautiful parabola. It's exactly what I expected. You? Is that what you expected as well? Good. And then tab. So then I have 2x plus 1. Where do I expect it to cross? 2, 1, 2, 5. Is that right? Negative 3, 1, 2, 3, negative 5. Is that right? Now, I just guessed at that, right? Is there a way I can know for sure? Menu, analyze, intersection. Remember that? Just go down the left-hand side and hit enter, or not enter, but the middle button, right-hand side. There it is, right down there. Can you see it? Negative 3, negative 5. Yes! Menu, analyze, intersection. Put it on the left-hand side of this intersection and pull it to the right-hand side of the intersection. And there it is. 2, 5. Yes! So they both showed up, right? They both worked, so they're both solutions. Is there another way I could have figured that out, that they're both solutions? How? Either the table, or I could have put it directly into both of these equations, the x and the y, to make sure they were equal, right? Okay? Yes, the table for sure. That's if I had a calculator. If I didn't, so I couldn't graph it, the other way I could know to do is put it into both equations. Make sure they both work. Okay? Questions about this? How do you feel about this? Confident? Pretty confident? Yes? Okay. Please circle the following problems. Number 2, number 4, number 9, number 13 and 14. And 16 and 19. 1, 2, 3, 4, 5, 6, 7. So you should have 7 problems circled. Yes? 2, 4, 9, 13, 14, 16, 19. God bless you. Any questions about any of this? We good? Ask if you need to. Use your technology for the first half of this assignment. Use your calculator. That's the purpose of today. It says up there that I have to teach you stuff on your calculator. We've done all this by hand before, right? We've done it all by hand. Today we get to rely on our calculator. Okay? Mark, it's that go.